we will discuss equations of motion. Whenever body moving with uniform acceleration, at that time these equations we will tell. First of all, u means initial velocity, v means final velocity, s is displacement, t is time of travel, Sn is distance travelled in nth second of its journey. First equation, v is equals to u plus at. Second one, s is equals to ut plus of at square. Third one, v square minus u square is equals to 2as. Fourth one, Sn is equals to u plus a into n minus half. After taking LCM, this is one more step. We will write a by 2 into 2n minus 1. This is also correct. Same these equations only in different conditions we will write like this. Suppose body is freely falling. At that time, whenever body is freely falling, at that time initial velocity not there. Initial velocity value is 0. Body is moving downwards. That's why acceleration is equals to g. Acceleration due to gravity we will consider. These two values will substitute in first equations of motions. At that time we will get values. First of all, in first equation, v is equals to u plus at means u value is 0, a value is g. Remaining v is equals to g into t, like that. First equation it will convert like this. In this equation, first equation, u value 0 we are substituting. Initial velocity is 0. After that it will convert v is equals to gt. Same values we will substitute in second equation. S is equals to ut term get cancelled. U is 0, na? That's why ut term is get cancelled. Half into at square means instead of a we will write g. S is equals to half into gt square. Next, third equation, v square minus u square. U square means this is 0. Remaining v square is equals to 2as. Instead of a we are substituting g. V square is equals to 2gs. Next, fourth one, Sn is equals to u term is 0. A is goes to g. Sn is equals to g into n minus half. This is the in the case of freely falling body. Next, third one, equations of motion for a body throw vertically up. Suppose we are taking one body, we are throwing upwards. At that time, that body is goes opposite to the gravity. That's why a value we are taking minus g. Displacement it is going upward upside, na? That's why displacement is in the term of height we will take. Now these two values we will substitute in first equations. Yes, v is equals to u plus at means u as it is. In term of a we are substituting minus g. S not there na in first equation. V is equals to u minus gt. Next, second one, instead of s we are substituting h, height. H is equals to ut minus of gt square. Minus means instead of a I am substituting here minus g. Next, third one, v square minus u square is equals to 2gh. Instead of a means minus g, h means s means h. Next, fourth one, Sn is equals to u minus instead of a minus g into n minus half. These are in the case of body thrown vertically up. Equations of motions. These equations of motion we will prove using graphical method, graphical treatment. Now we are taking a VT graph. VT graph, it has initial velocity u. Whenever body is moving with the uniform acceleration a. Here u is initial velocity, a is uniform acceleration. After t seconds, velocity after t seconds v. Yes, at that time in the graph AB straight line it will come. Yes, whenever we will draw velocity and time graph, x-axis time, y-axis velocity we are taking. This body already has the initial velocity u. After t time, what is the graph? A, B. Now using this graph equations of motions one by one we will prove it. Here first equation, velocity as a function of time. First equation, velocity as a function of time. That means v is equals to u plus at we have to prove. That purpose in this equation I am taking slope of the graph. Slope of the graph means AB straight line is there. Slope means this tan theta only, it gives acceleration of the particle. That means slope of velocity time graph gives acceleration of the particle. Means slope means tan theta. Tan theta is equals to, suppose we will draw one parallel horizontal line to x-axis A and C. A, B, C, one right angle triangle is there. Now tan theta means opposite by adjacent. BC by AC. BC means total B and D is V. AD is U. I want BC only. BC means we will subtract from total V. From total V, U I am subtracting. Suppose this BC total 10 is there. CD 3 is there. I want to BD 10 is there. CD 3 is there. For example, I want BC only. At that time 10 minus 3. 10 minus 3, it gives 7. Same as it is. Total B and D, BD is V. Inside CD is U is there. I want BC only. BC means V minus U. We are getting this value BC. Substitute here BC value. BC is equals to V minus U by T. Here on x-axis T. Same, this is parallel only na. That's why this is also AC also T only. BC means V minus U. AC is T. Now this tan theta gives acceleration of the particle. These two terms compare it. V minus U is equals to, after doing cross multiply, AT. V minus U is equals to AT. V is equals to U plus AT. This is the first equation of motion. Velocity as a function of time. Next second one. Displacement as a function of time. Displacement as a function of time. Second equation, S is equals to ut plus of at square. Now how to we will get this equation? Whenever graph is there, under the area of VT graph gives a displacement. We want displacement na? Under this area of graph gives displacement. Under this area means we can't find out this directly. That's why we are dividing two parts here. One rectangle ACDO, otherwise OACD. Next ABC. Here the area under the velocity time graph with x-axis gives the displacement. Remember that This is very, very important. Next, the area bounded by the line AB with the x-axis gives the displacement. Using this, we will find out second equations of motion. Now, total displacement under the area of this graph, total displacement means area of the rectangle plus area of the triangle. What is the area of rectangle? Area of rectangle means length into breadth. OA into OD. What is OA? OA is U. OA is U. OD is T. Substitute these values. OA into OD, U into T plus area of the triangle. Area of the triangle means 1 by 2 into base into height. Base is AC, height is BC in this triangle. AC is T, CB is V minus U. Now, here from first equation, V is equals to U plus AT. Should send this U value left hand side. V minus U is equals to AT. This value substitute in this equation. Instead of V minus U, AT should substitute is from the first kinematic equation. Now we will get it. S is equals to UT plus 1 by 2 into T, same as it is. Instead of V minus U, from first equation V minus U, AT you should substitute here. T into T, T square. Now we got it. S is equals to UT plus of AT square. This is the second kinematic equation from using a graphical method. Same formula we will get it in general method also. In general method, we will find out S is equals to UT plus of AT square. We will do that. Whenever particle is moving with uniform acceleration, average velocity, final velocity plus initial velocity by 2. Average velocity of the particle whenever body is moving uniform acceleration. Next, displacement. Actually, displacement is equals to velocity into time. Instead of velocity, we are taking average velocity. Average velocity is V plus U by T. V plus U by T into 2 into T. Now, here V, U plus V, V means from first equation V is equals to U plus AT. Substitute instead of V, U plus AT. Now, U plus AT, already U is there. This is 2U by 2. T should multiply it plus 1 by 2 into AT square. Finally, 2 to get cancelled. UT plus of AT square. This is the general method of equations of motion, second equation. Next, same equation we will write like that also. Position as a function of time. Suppose this displacement is final and initial is there. Position of final is equals to xi. Position of initial plus ut plus of at square. Next, fourth equation. Fourth kinematic equation. This is the velocity as a function of displacement. V square minus u square is equals to 2as. Here V is equals to u plus at from first kinematic equation, means these equations of motion, one more name, kinematic equation also we will tell. V is equals to u plus at. This initial velocity send left hand side, V minus u is equals to at. This is the first equation. Next, displacement is equals to average velocity V plus u by 2 into T. These two equations means after doing cross multiply, V plus u is equals to 2 into S by T. That means this 2 it will go as a multiply, T it will come as a divide. V plus u is equals to 2S by T. these two equations using first one and second one should multiply these two equations, left hand side and right hand side. V minus u is v into u, v plus u is equals to v minus u at right hand side, 2s by t should multiply, t get cancelled, remaining 2as. This is the in term of a plus b into a minus b. A plus b into a minus b, how to we will write? A square minus b square. B square minus u square is equals to 2as. This is the fourth kinematic equation, fourth equations of motion. Now these are the other formulas using kinematic equations. Suppose ratio of displacements in the first, second, third and as nth second. What is the displacement in nth second? Fourth equation is there. This is the third one. Fourth equation is there. Sn is equals to, this is the third one. Fourth equation, Sn is equals to u plus a into n minus half is there. Na? In that we will substitute values. That means 2n minus 1 is there in that. 2n minus 1 ratio of displacement after substituting first, second and second and third second at that time. Displacement, how to we will get 1, 3, 5 up to 2n minus 1. In this 2n minus 1, we will substitute n value 1, means first one 1, n value 2 means 2 to the 4 minus 1, 3. Like that our numbers we will get in the nth one, in fourth kinematic equation. Next, ratio of displacement in first, second and first, third second. At that time, displacement means second equation, s is equals to ut plus half at square. T value is in term of square only. Now that's why first one means 1, second 2 square, third means 3 square, 9. Like that we will get in the ratios. These four equations of motions are very important for doing problems. Yes, you must learn these four equations of motion. Please like, share and subscribe our channel. Thank you.